All right, in this video, we'll be talking about linear approximation under binomial expansion. The whole concept of linear approximation is a situation where you're given a particular expression to expand, and then you would have to make use of that particular expression, the expansion, to estimate an approximate value for a particular uh, arithmetic. For instance, you may be told to solve, let's say, 1.03 raised to the power of 12. This is a situation where you'll be told to apply linear approximation. Now, if you look at what we're having here, generally you can press this on a calculator. That means it's not impossible to get the value of this on a calculator. But in a question where you are told to use the concept of binomial expansion, you'll be penalized. Actually, you won't be marked correctly if you just fix in this on a calculator and write the answer. That would be wrong when writing an exam. So what you have to do is to follow the process to arrive at the correct answer. So let me quickly give you the basics of linear approximation when dealing with binomial expansion. So the general situation is you'll be given a particular expression to expand. For instance, let's say you are given 3 minus 2x raised to the power of 12. So you'll be told to find the expansion. In some cases, like in the example we're going to be solving in a couple of minutes, you can see that we're told to find the first 4 terms. That means in this case, you're not expected to expand the whole thing. You're expected to just arrive at the very first 4 terms, and that will be all. So it's very fine if you do that, because you will still get your answer using that particular first 4 terms. In some cases, it could be the first 5 terms. So it's still very fine, and your values will be intact. Now, let me tell you this: when dealing with binomial expansion, and you're trying to solve linear approximation, you must take note of the power. You can see right here that the power for this expression is 3 minus 2x. You can see that raised to the power 12. Now, if you are supposed to find an approximate value for any expression, anything, any arithmetic, the power of that arithmetic must be the same as the power of the expression you were to expand. This is the only situation where you would be able to use this concept for solving. So in a case where, take for instance, you had a question like this, you were given 3 minus 2x raised to the power 12, and you are told to use this to find 1.03 raised to the power of 10. This will be impossible. So this doesn't work. So the general concept is that you must have the very same power, and you will be understanding the reason why very soon. So this is one of the first basics while dealing with linear approximation under binomial expression. You must note that the power for the expression you were to expand was the same thing as the power of the question you were given to find the linear approximation of. All right. So now, that being said, the very first thing you have to do in any question you're given is to expand the expression. All right, that's the very first thing. Then from that expansion, you will then be able to use that expansion, the values in that expansion, to get your final answer. So let's go right into this very first question, and let's see the concept around linear approximation. All right, so I would not be solving this particularly because we have other videos that has explained on how to expand this. But 1 minus 2x raised to the power 10, if you go on with expanding this, you would arrive at the very first 4 terms to give you 1 minus 20x. This will be the final value when you're done solving. 1 minus 20x plus 180x squared minus 960 x cubed. Of course, this doesn't end here. It keeps on, it continues. So, but we're told to find the very first four terms. All right. Now, just in case you are new to this concept and you want to understand how we arrived at this result, I'll just give you the basics. Of course, while dealing with binomial expansion, the basics, if you were supposed to do this to arrive at this, would be you would have to go on with solving 10 combination k, 1 raised to power 10 minus k, and minus 2x raised to the power of k. So this is what we solved in order for us to arrive at these values we got here. So this is the general theorem. And this k value, as you can see here, it ranges from 0 up until whatever the n value, that's the power of the expression. You can see the power of this expression is 10. So my k will be ranging from 0 to 10. So if you wanted to expand this fully, you go on, this is summation. So you go on to solve, the very first term will be when k was 0. You had that with the second term, which would be when k was 1. And you had that with the third term when k was 2, on and on and on, up until you get to when k was 10. Now, but for this question, we don't need to do for k being 0 to 10. We only need to do for when k was 0 as the first term, when k was 1 as the second term, when k was 2 as the third term, when k was 3 as the fourth term. So that will give me this particular result. If you go on to solve that, that means fixing k as 0, you'll get 1. You fix k as 2, you get minus 20x. You fix k as 3, you get 180x squared. You fix k as 4. Sorry, 0, k as 0, k as 1, k as 2, k as 3. If you fix k as 3, you will get minus 960 x cubed. All right, so that's the general thing we did to arrive at this result. So now the real concept of linear approximation, which is the basics of this video, let's get right into it. So having gotten the very first part of the question, that means we've been able to get the expansion for the very first four terms, which is what is seen right here. We can go on to solve the second question now. Now, the second question said we should find an approximate value for 0.98 raised to the power of 10. Now, you can see 0.98 raised to the power of 10. As I told you earlier, you have to have the same power in order for you to be able to solve this kind of expression. You can see 10 here, you can see 10 here. So that is quite all right. So that means this is solvable. So we can go on now to use the concept of linear approximation to get our values. Now, what we have to do here is, if you look at this place, we can see 1 minus 2x here. We can see 0.98 here. Both are raised to the power of 10. So what we need to then ask ourselves is, what will be x? What should my x be for me to turn this whole 1 minus 2x to 0.98? So what value should my x be that will convert 1 minus 2x to 0.98? Whatever value x was, all you would have to do for you to arrive at the final result for this, you go on to fix that value of x into this expression, and that will give you your final result. That's the entire concept. So in this stage now, I want to ask myself, what should be x for me to arrive at 0.98 for 1 minus 2x to give me 0.98? You don't need to crack your mind so much on that. All you need to do is to go on with a mathematical argument, and which is very simple. All you say is 1 minus 2x being equals to 0.98. Of course, from there you'll be able to get yourself the value for x. So if you go on to solve this mathematically, you can easily cross this to this side. That will be 1 minus, you bring this here, 1 minus 0.98, of course, equals to 2x. If you can see what's going on here, this will be 0.02 equals to 2x. Get my value for x here, I will have to divide both sides by 2. my x will be 0.02 divided by 2, which is 0.01. So you can see right here that from what we have done now, our value for x being 0.01 will turn this entire 1 minus 2x to 0.98, which will imply that I can go on then to fixing x as 0.01 into these my expressions, and I will be able to get my result. Of course, so I can write it right here that x is equals to 0.01. All right. So I want to go on now to fixing x as 0.01. So I can therefore say that 0.98 raised to the power 10 will be equals to 1 minus 20, now 0.01, plus 180, 0.01 raised to the power 2, minus 960, 0.01 raised to the power 3, plus on and on and on. Now this, of course, we are only going to be using the very first four terms. So this I fixed here is just telling you that this wasn't the end of the expansion. So you go on to use your calculator to solve this. And if you fix this on a calculator, you would have 1 minus 0.2 plus, if you put this square and you multiply it by 180, you'll be getting 0.018. And if you fix this raised to power 3 and multiply with 960, you will get 0.00096. All right. Now, don't forget, always take note of what you were told to fix your final result as. You were told to give the answer to 3 decimal places. So 3 decimal places, of course, if you get the sum of all these to 3 decimal places, you get an approximate value of 0.817, which is the final result from my calculation. All right. Now, I want you to note one thing, that if you generally go on to press 0.98 raised to power 10 on a calculator, if you go on to check your calculator value, you will notice that your values was the same thing as this. So if you check it on a calculator, what we actually got was 0.8170728069. So you can see right there that it's not going to be different. It's going to be the same answer. So all we're using now is just using the concept of binomial expansion to solve questions without having to use a calculator. Now, there are certain questions that you could always see. For instance, they could tell you to calculate the error, or sometimes the percentage error that happened from using the approximate value. So in that case, all you have to do is to get the true value. This is the true value. The true value is always going to be the calculator value. And this was your approximate value, which was gotten from linear approximation. So what you have to do then is to make a subtraction. That will give you the error in the calculation. So if you do this minus this now, of course, that will be 0.00007 and so on. That will be your error. And then if you want to find the percentage error, you go on to follow the process. Let's solve a question that has something like this, and let's see how to go about that. All right, let's see this particular question. Quite similar. You can see where to find the very first 5 terms in this particular question. And the expression is 1 plus 2x raised to the power 12. And I told you already, for you to find the approximate value, you have to have the same power. So you can see we are to find the approximate value for 1.02 raised to the power 12. And we're to give our answer to 3dp. No, I don't think we have to be specific here. So anyway, we would ignore this 3dp. We will not leave it in 3dp. We'll just give an approximate value for heat. All right, so let's try and solve this very quickly. So we don't have to waste much time on the expansion because I believe we have clear understanding on how to go about that. So the very first question right here, that's finding the very first five terms. So what I will just do is to write the expression right here. So for the very first five terms for this 1 plus 2x raised to the power 12, we're going to have 1 plus 24x plus 264x squared plus 1760x cubed, then plus 7920x raised to the power 4. So this is the very first five terms in this expression. So what we have to do next is to solve the part B, which was to find an approximate value for 1.02 raised to the power of 12. So the approach to this, as I told you earlier, is, of course, your expression before was 1 plus 2x raised to the power of 12. So what you have to ask yourself is, what should be my hex that will turn this entire 1 plus 2x to 1.02? So what value should my hex be that would make 1 plus 2x equals to 1.02? So you don't have to rack your brain on that. All you have to do is go on to write this as an argument, a mathematical argument. So you have 1 plus 2x being equals to 1.02. So you want to find out what should be your value for x. So 2x here will be equals to 1.02 minus 1. Because 2x here will be equals to 0.02. And your x value will be equals to 0.02 over 2, which will give me a value of 0.01. So I can go on to say my x should be equals to 0.01. All right. So what I need to do next now is to fix in my value of x into this expression, which was the expression for 1 plus 2x raised to the power 12. So my x value will be 0.01 if I was going to arrive at 1.02. So I'm okay with fixing that into this expression. So I have 1 plus 24, 0.01 plus 264, 0.01 raised to the power 2 plus 1760, 0.01 raised to the power 3 plus we have 7920, 0.01 raised to the power 4. All right. So if you go on to calculate this, you'll be getting 1 plus 0.24 plus 0.0264 plus 0.00176, then plus 0. Let's see if it contains here 1, 2, 3, 4, 792. All right. So the approximate value for this will obviously be 1 point, if you calculate all this, 1.2682,392. So if you go on to calculate it, this is the approximate value for 1.02 raised to the power of 12. All right, so we've been able to solve question number B. All right, the last question we have here is question number C, where we are to determine the error in this approximation. Now, to find the error in this approximation, what you have to do is just true value minus approximate value, that's the error. So to find the error, just remember that the error is always going to be equal to the true value minus the approximate value. I want you to understand one thing though. Uh, in some cases, you may have the true value being larger than the approximate value, and possibly in some cases, maybe the approximate may be larger. But in any case, just note that the error doesn't necessarily move with a sign. So you want to always fix it on a positive side. So you don't have to, positive or negative is not what really matters. All you're trying to find here is the distance between the true value and the approximate value. So you don't have to focus so much on the sign, all right? So in this case now, how to get the true value, you will have to go on to press this 1.02 raised to power 12 on a calculator, and then you will subtract the approximate value from that value, which was this. So if you press this on a calculator, what you will get was you'll be getting 1.26. I already told you that the values are not always far apart, because that's one way to know if you're actually correct or not. If you press your normal 1.02 raised power 12 on a calculator and your value is far from the approximate value you got, that's telling you you have made an error somewhere. So that's a good way to check up your work when in an examination, because your values are not going to be, look at what your true value was, look at what your approximate value was. You can see they are the same thing, almost the same thing, just with a very slight difference, which is what will be seen as my error. So you don't have to get a very far apart value. Like for instance, imagine you got your approximate value to be 1.5. That's telling you are wrong already. So you have to be very careful. Of course, if you go on to solve this, you will get a final value of zero. The error will be 0.000000259. That's the error. You can see you had it small, but of course still significant when talking about error. All right, so this will be where we would be ending this particular video. So we'll continue in our next video on more aspects of linear approximation. All right, guys, see you in the next video.